We'll consider some physical and chemical changes. I'm going to begin by taking a small amount of sodium bicarbonate baking soda and adding water to that in the test tube, and then mixing the two. And one way to mix it is just to hold the test tube by the neck and then swirl the liquid by hitting the bottom of the test tube. And you can see that most of the sodium bicarbonate is now dissolved. Is this a chemical or a physical change? And that's always a good question to ask the students when you're doing some work on chemistry. A chemical change results in new products being formed. A physical change involves things like melting, boiling, a change in state in other words, or dissolving substances. And all that I'm doing here is dissolving the sodium bicarbonate in the water. So this is really a physical change. Much the same as when you dissolve some sugar in your tea or coffee, or sugar in water. Now I'll take some hydrochloric acid. I've got some 1 molar hydrochloric acid here, and we'll add some of that to this solution. And you notice that as soon as I add that, we have lots of bubbles being formed. Is that now a chemical or a physical change? Well, obviously, we're forming a new substance. In this case, a gas is being generated, and that gas is a new product, and hence this is an example of a chemical reaction. What is this gas? Well, let's see if we can do a test for it. I have here a solution of lime water, and I'm going to pour the gas that was generated in this test tube into the other test tube. I'm not going to pour the liquid in, just the gas. And now we'll shake this up. And look at that. It turned cloudy. What does that indicate? That's now a test for carbon dioxide. And so the gas that is generated when I add the hydrochloric acid to the sodium bicarbonate is carbon dioxide. Why can I pour the gas? Well, the gas pours because it's more dense than air, and when I tilt the test tube, the gas then runs out from the one test tube into the other, settles on top of the lime water solution, and when I shake that, we get the formation of the white precipitate of calcium carbonate. Next, we'll take some copper sulfate solution, a nice blue color, and I'll add some to the test tube. And to make a little bit more of the solution, I'll just dilute it with some water. Then we'll take some sodium hydroxide solution and add that to the test tube. And when I shake that up, notice the blue colored solid being formed. Is this a chemical change or a physical change? Well, I'm again getting a new substance, and so therefore that must be a chemical reaction. The new product that I'm forming here, as the sodium hydroxide and the copper sulfate react, is copper hydroxide. And the copper hydroxide is a blue-colored precipitate that you can see in this test tube. Another example of a chemical reaction. Now we'll take some washing soda, a common household chemical again, which is sodium carbonate. Put a small amount in the test tube and add water to that. And again, we'll shake it up to dissolve most of the sodium carbonate. In this case, it doesn't dissolve totally because the commercial sodium carbonate that is used as washing soda actually contains some other chemicals in it as well. But now let me take some of the copper sulfate solution and add a few drops of the copper sulfate to this. And you can see as we shake it, we're again forming a precipitate of copper carbonate in this case. The copper ions in the solution from the copper sulfate react with the carbonate ions to form a solid compound. Again, an example of a chemical reaction. The dissolving of the sodium carbonate, what I did initially, is an example of a physical change as the sodium carbonate dissolves. Adding the copper sulfate to the solution forms this blue precipitate of copper carbonate. Let me take some sodium carbonate again. Put a small amount in the test tube, and as before, dissolve it in water. Again, this is a physical change as the sodium carbonate goes into solution. Now we'll take some of the hydrochloric acid again and add that to this solution. And again, we get the formation of a gas. More carbon dioxide is being generated again as the sodium carbonate reacts with the hydrochloric acid to form carbon dioxide gas. Now, we don't have to put the sodium carbonate in solution first. I can just put it in as a powder into the test tube and then add the hydrochloric acid directly to that. And you can see that again, we're generating lots of gas as the hydrochloric acid and the sodium carbonate react together to form carbon dioxide gas. In fact, I can take any carbonate compound and react that with an acid, and we get carbon dioxide gas being generated. This is, in fact, a test that we often use for the presence of carbonate in rocks, for example, such as limestone. Here I have some pieces of marble. And I'll just take a couple of these pieces and put that into a test tube, and then we'll add some hydrochloric acid to that. And again, when the hydrochloric acid is added to the marble, you can see the fizzing that occurs. Here it is once again with a little bit more of the acid added. Now, while it's busy fizzing, I'll take some lime water solution from my lime water bottle. Pour that into a second test tube, and now direct the gas that's being generated into my second test tube. And when we shake that up, we again get a cloudy suspension indicating the presence of carbon dioxide, which then came from the first test tube. So when I add hydrochloric acid to marble, it produces carbon dioxide, indicating that my marble contains a carbonate. The carbonate in this case is calcium carbonate. We'll now demonstrate a reaction between the copper sulfate solution and household ammonia. I put the household ammonia in a little dropper bottle so that I can dispense it more readily. So we'll take some copper sulfate, put it into the test tube, and I'm just going to use a small amount, add some water to that so that I have a dilute solution. So you can see that it's a pale blue color against my white lab coat. Then we'll add some of the ammonia solution to that. And notice that it first of all turns kind of cloudy and form a precipitate. And as I add more of it, it actually forms a deep blue color and it all dissolves. Isn't that a pretty color? In this case, when I first add ammonia to the copper sulfate solution, we're forming a precipitate of copper hydroxide because the ammonia is a base. And so there's some hydroxide ions present, which causes the copper ion to precipitate. As I add more ammonia, the ammonia reacts with the copper ion to form what we call a copper ammonia complex, which has this deep blue color. Let me now show the same reaction using even less of the copper sulfate. So again, I'll take some water and add now just a drop or two of the copper solution to it, and you cannot even see the color of the copper ions. As I add the ammonia to it, the ammonia now causes the deep blue color, indicating the presence of copper ions. This is actually a test that is sometimes used to detect the presence of copper ions in a water sample. The ammonia forms this intense blue-colored complex that indicates that copper ions are present in the solution. Again, this is a chemical reaction because the ammonia itself is reacting with the copper ion to form a new compound, this deep blue color.